needs a lot of space. So first things first, we need the float values of the positions. So we're gonna have to break down the vector to float values. That's the three main components of the vector. And to know, essentially, eventually, we're gonna be, joining the whole thing back up. So we're actually gonna make a float to vector, so that way we can just bind this thing back up. So we're gonna bind the x and the z don't change at all. We're always messing with the y values, and pretty much if I plug this in, nothing changes, so everything still remains the same. So we need to do the little slash over here means absolute, and that's what we're gonna be doing with this. So we gonna let's try this. Cosine of x, so we're gonna drop in a trigonometry function. So cosine of x, oops, so this one is cosine, okay, plus the cosine of z, so we're gonna drop another trigonometry function. So that's a cosine also, and you're gonna add them up. So I'm just reading over here, so I'm just reading the inside over here, so that's addition. So you're gonna do an add of this to this, and once you add them up, what you need is the absolute of the whole block. So in Vops, there's the absolute, and just gonna plug that in over there. And what you need to do is actually raise that to power of 0.5. So we got a POW power, and well, as well, you can just come over here, type in the exponent, or you can have a parameter depending on what you want. Now 0.5, 1 over 2 is actually 0.5, so you can just hard code that whole thing to 0.5, or you can have it as a parameter on the top, it doesn't matter. Then pretty much that's it. All we gotta do now is actually just plug in that to the y function over here, and as you can tell, we got some good looking stuff over here. I'm gonna go ahead and take out the grid, and you can tell what we got. So that's pretty much where's that guy? I don't know, but he's somewhere over here somewhere. So you can look at that, and actually if you go ahead and let's play with the power over here, what do we get? We get, depending on what, I guess 0.5 would make more sense. It's a little bit more defined, and I like that. So now this is what I was saying prior to this. If I just copy this, copy the whole thing, go back to the same one level up, go over here to the Vop, I can actually paste the same nodes back in, because all of them are just the same nodes pretty much, and all that's left over here is just plugging in the output, and well, you get the same effect all over again. So pretty much working in Vops or chops result is the same thing depending on the context that you're working in. All the nodes remain the same basically in Houdini. So we got that running. I'm gonna go back to Vops since I want to see little dots. And I'm gonna probably max the points a little bit to 100 by 100, so that way you get a little bit of a smoother. I'm probably might change this to a NURBS also, get a little bit smoother. And I'm gonna go ahead and drop in another Vop pop, and essentially it's gonna do the same thing all over again. So let's get our thing over here one more time, and we're gonna do, essentially we've done this one, think about it. So we're gonna do, and what's the difference between this? Let's try number 13. So we're gonna do the same thing all over again. We're gonna have a vector to float, and we're gonna want a float vector to go back and rejoin the whole thing. And if you plug that in back into the original to the output position port, nothing changes since everything's still the same. So number 13 says cosine of x to the power of 2, power of 2 to the power of z added up to get the cosine of it. So okay, so we're gonna get an addition gonna be adding up. No, actually, my bad. We're actually getting the power of this to the power of 2. And you can have this as a parameter, by the way. It's much easier probably. So plug that in, and you can have this as a value of 2 in our case. Then we need another power for the z, so power for the z, which gets the same exponent. Then you're gonna add those up, and once you add them up, you're gonna need the absolute. So we're gonna get the absolute of this, and you're gonna raise that to a half. So we're gonna need another power, and this one is gonna be 0.5. And pretty much all that's left again is just to drag this over here and plug this in right here, and you get that shape right there, whatever that shape is. And you know, you get your little parameter right here. It does a few, you know, interesting things. So you can raise it up to 2, becomes this little, I don't know what you want to call it, but you know, it's kind of interesting, the shape that it's actually putting out. And you know, you'd have to mess with some of this stuff just to get an idea of the whole thing. I'm gonna go ahead, let's make one more. Let's make one more. Nah, that's enough for Vops. Well, let's probably make one. Nah, that's enough for Vops. Let's go ahead and jump into the last portion, which should be Python. Now, Python is gonna be a little bit interesting because well, it's all code and nothing else. So let's go ahead and jump into Python and see how that works out. Okay, now whereas I was saying it was over with Vops, I actually like to say it ain't. Now here's the deal. I remember in a video that I saw a while back, he had the particles emitting, and they had different colors depending on the particular location that they were in. Now in our case, you can actually go ahead and do a little what you call it? You can do a compare. You can do a little compare, and you can actually test whether the value over here is actually less than 0.25. I would say something small, not too big. And if it is, you can put the particle in a particular group. So actually you can do a utility if then block. So you can actually do that as true, and if it's true, what you want to go ahead and do is actually get the point number and plug it in right here, and you can double click on the if statement, and you can actually just go ahead and add point to group, and the group is going to be called emitter, or whatever name that you want to name it. So now you actually have a group over here which has 584 points in it, of which it depends on what you typed in the compare. So actually, if you wanted them, the ones on the top to be emitting, so you'd have those, and pretty much if you wanted to add color to them, you would actually do the same thing. I would say you'd use the if. I think that would work. I did with it. You can just use a two-way switch also. You don't have to you just use it like this, and you can do a float to vector, so that way you can create a color attribute. A color attribute is actually a vector also, 3 float vector value. So you can put the value to red. 100 is red, and if you want a blue, you'd actually copy this, paste that, and make this value over here blue by putting a 1 right here and a 0. Okay, so RGB, so blue at the very last portion. So if I plug this in over here and plug this into the color, what I get is this, and pretty much I might want to increase my little compare thing over here to a little bit higher of a value. And now I can have this little portion as an emitter, so I can actually now have a split split, which splits this particular group of a matter from particle breadth, probability of that, and life probably of 1, life variance of 0 point, some number. Then hold up, is it emitting anything? Velocity, we need to increase some velocity, so it set initial to 1, variance to 0 point, some low number, not too high, and ooh, that's to have a birth rate, so probably lower. So go back up, and wow, still too much, but you get the point. So basically, you don't want too many particles if you ain't got too much memory like I don't. So play, and now you get only this particular portion of the whatever's being, emitting particles. And let's call that a wrap for Vops, please. Now let's go ahead and dive into Python, so we can actually go ahead and wrap the whole thing up. So pretty much you can imagine any kind of changes that you make with as far as for the trigonometric functions over here, the whole thing is upstream, so, or downstream, whichever one you want to call it. And pretty much over here, forget the value and mess with it a little bit, you get all kind of results. So time to play with Houdini, I guess. Okay, so that's enough of Vops. So we're gonna go ahead and drop it on null over here, and we're gonna name it Python. That's what we're gonna do next. Okay, so 2 more functions, and we're gonna call it a wrap. So we're gonna do this specifically in Python. So we're gonna be coding this stuff. So to begin this, we're gonna actually go create a new operator type, and we're gonna name it we're gonna deal with function number 17. So just got the new keyboard, I ain't got a hold of it yet. And oh boy, function 17 is going to be a Python type, and it's going to be under the geometry operator type. So I must say, well, you might want to name it something a little bit different, so yeah, custom function some, and yeah, current pip file and accept. It opens up a type properties page, and at the same time, if you actually go to the digital axis, now you got this function 17 node over here, which is actually a custom node which actually code this stuff. And once your stuff is coded, that once the code gets executed, you see results in the viewport. So in our case, we're gonna be doing with cosine and all that kind of good stuff. So I'm gonna go ahead and actually import the math module, so that we can actually do math in Houdini. And typically it begins with this little code over here, but we're going to be dealing in points, so I can actually just go ahead and get all the point attributes in the geo object. So I'm going to just go ahead and type in dot points, and that's going to just give me all the points on the geometry on our grid over here. So now I actually have all this. I'm currently naming geo points to make it more sensible. So now you have geo points having all the point numbers, point positions, any attribute related to points is actually being held in this. But actually all we need is actually just the positions and nothing else. So we can actually go ahead and use a for loop, so actually we can iterate through all the points. So for every point in geo points, right? If I can type, got this new keyboard as I said, and I'm not really liking it. tab in, we're gonna actually get a position x of every single point. So for every point, so we're actually gonna say point dot position to get the position of it. And this actually gives us a vector, or gives an array that they call, or a list, or a tuple, whatever you want to call it. I believe it's a tuple that it gives out, or a list. But the thing is, it's actually iterable, so you actually index the values. So in that case, we need the x value, which would actually be 0, meaning that's the very beginning of the list. So that would actually give us the x value of every single point. You also need the position value of every z point of the every, the you get what I'm saying. I'm actually just copy this, being that I'm lazy. I've learned to be lazy by just learn a little bit of Python. And the z value is on the second position of the array that gets outputted by Python. I'm not sure whether it's a list or tuple, but it's either one of them. Regardless, you still gotta, iterate through the point, index through the point positions. So we're doing number 17 over here. So I'm actually going to copy that, and I'm going to type in, put a comment. So I'll put a hash character, and I can paste this. So I'm actually going to be doing cosine of x plus the absolute of x plus the absolute of z. Use that as a cosine. So being that actually just messing with the y values, I'll just create a new variable named position y, and it's gonna do. If you remember, I actually imported the math module, so that way we can actually if I do this real quick, Python shell, and I say plot math, and I do a dir on math, you can see we got well, where's the cosine and sine and all that kind of good stuff. And that's actually why we imported the math module. So in our case, we're gonna need to do a cosine of all of that stuff. So we're gonna do a math dot cosine, I guess close that first, then we're gonna go ahead and do an absolute. So math dot, that's the value that you want, and you want the absolute of position x. Okay, and that's gonna be added to, it's gonna be added to the z value. So we're gonna do the same thing all over, only this time I'm gonna copy this and I'm gonna paste it. I'm gonna just change the value over here to z, and that's pretty much it. So pretty much you can actually check whether the whole thing encloses. So you can see that that encloses that portion, that encloses that portion. So just make sure that this one encloses the whole portion. And what's left to do as of right now is actually just set the point position of the whole whatever. So point dot set position, and it's expecting a tuple of numbers. So the first position will be position x, second position, yeah, that's a comma, so position y, and I like a little space in my stuff, and the last one will be position z, and I close the first one and the second one, and everything is finished. And pretty much, if you got errors, ain't nothing gonna pop up. Oops, that's gonna be red. If no errors, we're gonna have a shape right here. So apply, accept, and view this. There goes our shape. So pretty much, Pythonically, you also can create this stuff. And pretty much, if you actually do the next one real quick, so let's do this one, number 19. I'm gonna use the same operator over here. So what I'm actually go ahead and do is copy the whole of this and and actually go ahead and comment it out so it doesn't get executed by Python. Then I'm gonna go ahead and paste it one more time. Now the only thing that we're gonna change is this. In our case, we're doing a math dot sign of math dot power. I'm just reading as it is over here. So math dot sign math dot power the x value. So in our case, if you pause x to the power of 2, and you want to multiply that, so that's a whole function in itself. So we need to close this out, and we need to multiply that by the cosine of z. So actually I can just go ahead and copy this, and you can tell I'm really lazy, and this one is supposed to be cosine, and everything else pretty much remains the same, and pretty much that's it. You can just hit apply and you get your result out, and that's pretty much it as far as for Python. Ain't much to it for real. You just gotta learn how to tweak the stuff, and you can see kind of amplify. You gotta have to just play with the numbers, I guess. And pretty much that's it for me now, for real. I'm gonna just let you guys mess with that one and that one and that one. Them kind of long, kind of sorta. So I'm done. There's the file. Oh, actually, I'm not done. If you really wanted to put this in sensible way for demonstration purposes, for let's say a class or something, you would actually do a switch node, right? So in our case, you'd have this one, plug it in into the first port, and this one onto the second port. Essentially, you'd have all the and this one you can just select all of them at the same time and just plug them in at the same time. They'll go accordingly in order. And once you have everything plugged in, now you have an index value over here, which you can just index through. So it has all the functions in their respective indexes, which you're actually going through right here. Now what you actually need to do is actually edit the parameter interface for the switch, and you're gonna drop in an ordered menu right here, which under the parameters you might want to name it to something. Then on the label you're gonna name it functions, probably not in caps, but functions. Hit apply. So now you actually have a menu over here, but you actually need to fill up the stuff. So in our case, you're gonna do 1, and in my case, I'm gonna just use the values over here. So I'm gonna edit the comment. Then this is just an example. So I'm gonna take this, let's say this value to, let's assume, well, we know this was the last value that we did, so let's take that. Then I'm gonna put that as the value over here. Then I'm gonna go ahead and drop in a number 2 right here. Then I'm gonna probably give number 2 this value right here, because I think that's probably this value right here, since that's what we did before that last, I would say. I'm not sure, but again, I'm just assuming. Then go to slot number 3, and we'd give it whatever value that we did for slot 3, whatever function we did for slot 3. So for the same way. Oops, I'm typing the wrong spot. For the same way, then just take a value, copy it, paste it, and apply, accept. Now in our node over here, you actually got the whole drop down. This is 1, that's 2, that's 3, that's 4, but there's no connection between selecting the stuff over here. So what you actually need to do is actually link the 1 over here to the 1 over here to the 0 basically, and the 1 to the 1. So pretty much you're gonna index this to that. So you actually copy parameter and paste copied relative references. So in our case, we're on the first one. So if you go to the second one, you got the second value. So pretty much now you can actually just edit the parameter interface. And for this one, you can actually just, on the parameter, you can actually go ahead and make it invisible and accept. Now when you give this out to somebody else, they just switch through and, they just get the file, with all the nodes and everything, just, plug it in accordingly. So kind of cool, you know. And I'm pretty much done with this. So it's a wrap. Functions in Houdini. I mean, I know I didn't do all the functions, but there's more to it than it, seems. It's like forever, if anything. That's it for me. So hope you had fun watching this because that's a long tutorial right there. So I'm gonna see you on the next one for so out.